Okay. Hello. Thanks for joining this second session of reproducibility in science. So this time, Arturo will present reproducibility in practice. So once again, if you want to interact, feel free to use Slack or Gather Town. And yeah, that's for you, Arturo, now.
Thank you so much, Ayam. So I just want to ensure that you are seeing my desktop that in principle is only the browser for the moment.
Yeah, we can see it.
Thank you so much. So yes, let's continue with this. Now, as I mentioned, I'm sharing the entire screen because we will open a couple applications more. So yes, let's make an overview of some tools, no, for these different elements that we have been talking about: data, storage, software developing, and computing power also. So with respect to the data, again, usually the labs and experiment have dedicated data repository for the user. No, it's normal also, as I mentioned before, that
Arturo?
Yes.
I'm sorry to disturb you. We see your Slack notifications. I don't know if you want to.
Yes. Can I kill the application now? I guess that you can tell me if I miss something by voice.
Yes. Sorry.
Thank you. No, I was not sure. Thanks. Hopefully there is no more stuff. Okay. So yes, as I was mentioned, you will very probably are dealing or will deal with data that is stored in a particular facility that is allowed for the members of that collaboration. No, but we also want to mention, and especially follow this idea that Rachel brings the first day about some open access tool that you can use to properly distribute data sets. Even if it's for the time being it's only you who is using it, it still will be very, very useful to start to do it in the proper way from the very beginning. So I listed two that I find quite interesting. And once again, as I mentioned 2 hours ago, there is many options, maybe more than one way to do the same thing. And I'm just giving you a couple of examples. So maybe if some of you will be useful or trigger some ideas. So one was mentioned many, many times, and that's Zenodo, and it's here. So for those that have the slide in front of you, each of the image has hyperlinks, so have links to those resources. So in the case of Zenodo, that again was mentioned before, the idea is that you can store here any kind of digital object. I mean, you can put datasets again, any kind of dataset, but also allows you to do to store, for example, a presentation, a PDF, a paper, for example, a preprint, a white paper that you are writing, and you want to keep versions of that, videos, for example, classes, like what is happening right now. We can take these videos from YouTube and put it also as a record in Zenodo with a dedicated DOI and the author and all this. So for those who see it for the first time, let me make it a little bit bigger. But for example, here is one of the accounts that is open, and you can see that we use it for many things. In this particular example, my own space is a series of white paper for a conference that happened some months ago. So we essentially add the paper of other people. So that's also can be useful. In this particular case, I was adding the paper and also the different names and the people that was the authors and institution, etc. So how looks, I mean, without going too much into the detail, but something that I wanted to show also because it's correlated with this question about the metadata. As you can see here in the website, oops, let me come back, upload, new upload, thank you. So here, first is the file themselves that you want to, all the files notice that this also, here in Plural, you can, for example, have a collection of files that, again, imagine that it's a data set, and that particular data set has 10, 20 different files. So you put it all together, and that is a package that you identify with a unique digital object identifier with a unique DOI for that. So again, making a little bit bigger to some of these details are possible to be visible. There is a minimum one file is required. Yes, it cannot be an empty record, and a maximum of 50 gigabytes per data set. And that's at least for for a single user, we are pretty sure that will be more than sufficient to save a decent amount of data sets here. No. The other important thing that I would like to mention about Zenodo is the possibility to create communities. Yes, it happens sometimes that the collaboration of or a particular member of a team need to be the kind of curator of a data set or a collection of records or paper, for example, that I showed you just before. In that case, I can say I was the curator of this, but I was not the author of none of this paper, in fact. And so one of the things that are powerful also about Zenodo is that allows you to create these communities. So the communities is that once you have a series of records, you can include those a family of record into a community, and will be let's say indexed together. So again, you can choose from many. Obviously, there are communities that are managed by somebody else. So for example, if we are saving a record right now, and I choose one of these one, what will happen is that it will write a request to the owner or the person that are responsible for that community, and they have the power, let's say, to accept or to deny that application of this record to be part of the community. But again, it can be also very powerful when you put things together. And again, you also can create your own community. So it's not only one that is here. You can create your own community. For example, those papers that were there. Sorry, I forgot the community name, but it should be here. For example, it's Latin American Strategy Forum. So when I click in that particular community, yes, all the so you can see the curator here. You can add policies, things more complex, but essentially we have here I think the word 39 or something like that, white paper that were here. Yes, 39. You see, and in this case also adding to that answer on the metadata, something that is quite powerful is the keywords. Now that will allow you to as you can see here, I was extremely simple in my case, but you can be more specific and will be very powerful in order to filter, in order to index your data sets or your different records. So let me just come back to how it looks like this, the rest of the creation of the record. So again, there are several objects that you can include. It can be a publication, a poster, presentation, mentioned data sets, an image, a video or audio recording, pieces of software, a lecture, a physical object, and even other things that you can put there basically. Also, if there is a publication type, something that so the DOI will be created, but can be possible that you already have a publisher. Let's say that particular record already have a DOI, so you want to kind of mirror in this case publication day, title, obviously, author. Here is another part that is quite important for you guys to get also is your ORCID. That is essentially this unique identifier, in this case, to the researcher, to the analyzer, to the professional that is producing this kind of resources, because this will be allowed to also track in a proper way the authors of a particular, that again, record basically, and will also help you to create this kind of curriculum in the internet in a proper way. So again, I take the opportunity just to mention that obviously many of you are students and people are starting your career, and it will be extremely important for you to have a way to show to to your current supervisor or to future employees, etc., what are the different previous project that you have been working with, not only alone but also in collaboration. And the way that we are getting this is to get this ORCID that allows you to again identify a particular record with your name, with your authorship, let's say. And more platforms are including this field as part of the author, so you can you will start to build essentially your let's call it a portfolio or your curriculum, depending on the word you want to use. And again, this is especially quite important when you are creating software, when you are part of the collaboration that sometimes the traditional method of paper or citations on papers or patents is very rigid with respect to this kind of collaboration. When you are part of, for example, a team of 20 people that is creating a successful Python library, and this will be the way to others to track that you are part of those authors, that team. And so it's quite important that you get this if you didn't have it yet. Sorry that I stopped there, but I wanted to stress that, but because I feel it's an important subject, especially for as again, if students and people who is starting in these different activities. So saying that, you can also again put a description and be as explicit as possible. You have way to enhance a little bit the text, as many others content manager system. You can also add a version. That means that you can you will see let me show you later, sorry. But what's is also important is that, for example, imagine that you are tracking a software, a piece of software. So Zenodo have a direct connection with GitHub, for example, and they are currently developing also to do similar activity, for example, with GitLab. I will show you a little bit more about that. But essentially, when you are working with software, is something that will evolve. So essentially, you are doing releases, like when you download an application in your phone or in your computer, you have a release, and new features are put it together into a newer version, or maybe a bug fix, etc., and a new release is done. And so maybe you would like to do the same. You have a kind of sorry, I think maybe you'll see the notification on the email also. So let me quit that one also. Excuses. So yes, what I was saying is that in the case of software, you can still have Zenodo to track the development of a particular repository. So for example, you have a version 1, version 2, version 3, because you are doing different release, obviously improving your software, but there will be a unique identifier. So you can have several versions containing into this. You don't need to create a new DOI per release if it's something that is evolving, for example, constantly like that. This kind of feature can be useful also, not to don't disperse for example, the tracking of the software, because at the end it's the same software, but obviously in a newer version. Things like that. Keywords, as I mentioned, is quite important and very useful. Also, you have the opportunity to have the data in different ways. You can put it as an open access. So again, free to be downloaded, to be used by other people. You can have some embargo data. So that means that you are preparing a data set. So again, you are working on this and you put a date where this data will be released, no? For example, that can be quite useful also to be prepared and just automatize the moment when that happens to be open. Also, you can have restricted data. So there is some conditions that means that you can, if I remember well, you will be able to see the record. And so, for example, you find a restricted access record means that you can see for example, the title and maybe the description, and you can ask, so request access to that data set. And maybe this is why this box is here to say that there are some conditions that will grant access to any user that ask for them. So these other cases, for example, can be maybe something that you are doing. And obviously the last one is the closed access, that essentially is visible only for the people who has the author, and I think that you can assign other community, for example, that can see the record. Also have the possibility to track any funding. For example, if your data or software, digital object that you are putting there is part of a grant or part of a project, that you can also add here. There is a bank of different projects that you can search for. That also is quite important, especially again if it's coming from grant like the European Union, for example. But you can also, if it's something that yours, it's not a mandatory field. And there is, again, a bunch of extra information relative alternative identifiers. Again, if the record, for example, have another kind of identifier, like it's a book, no, or an archive, these kind of things that you can also add to this. Contributors that are in some way different to the authors, so also have this level of granularity here, and the ORCIDs, once again, part of the field that you should fill when doing this, and ask, or if you are part of a team, and encourage the people to get that identifier if they don't have it yet, basically. Reference journal, conference, this is so you have a lot of extra metadata that will essentially enrich the data set, and obviously increase the possibility that other people to find data set when they are looking for something like the one that you are including there. So yes, Zenodo is again quite powerful for this, and also allows you to create this community. Allows the community, we found it very useful, because, for example, you can have people who is external to your team that is creating, for example, resources, and they can apply for being part of the community, and you can kind of have a review process and accept it, and start to create, for example, what is written there, a community. Let's say it doesn't need to be, for example, your own team. This is what I wanted to stress. You can have people, for example, if you are releasing a particular software package that people is using and modifying it and making a derivative of this version, you can include as part of the community of other products that other people are building on top of the resource that you are releasing, for example. And talking about this, I forgot the last, that is quite important also. Yes, here is the license that is released. So, for example, here is very common to use Creative Commons attribution for international. That is essentially this kind of license that allows the people to do anything that they want with the data, but to, for example, it's quite important in science to ask to the person that is using the sample, the data set, the record, to acknowledge where this record come from. So have a kind of citation of this, that, for example, if this kind of license is, you have a product that you don't want to make people to make a commercial usage of the product for for whatever reason, for example. So you can set this license here, and again, Creative Commons is one of the most also more common, more standard in this kind of thing. So once again, coming back to the idea of using a standard, using protocols that are well known for the community, that will enhance also your resources and also looks much more into the professional, let's say. Also, it's quite important to have a license. Okay. So coming back to the slides, the other platform I found quite interesting is academic torrents. That is essentially is similar in the sense that you can upload a data set, again, a record in a similar fashion that Zenodo, but in this case also a torrent, so allows you to use this torrent technology to have access to the resources and to allow others to have access and to replicate the resources. So this is also quite powerful community-driven effort. And so here, if I remember well, academic doesn't give you the opportunity to have a DOI, but for example, you can have the same record in another platform and identify this torrent here with that DOI, no? And again, will allow to distribute this in a different way, that will increase the chances also for people. Once again, when we are talking about computer infrastructure, we are talking about internet connections, network, etc. Not everybody is under the same conditions. So torrent, for example, can be a very useful technology to use in some scenarios when you are collaborating with people that may cannot download, 50 gigabytes all at once, this kind of thing. And it also have a lot of possibilities to, let's say, to have the metadata, to include the big text to be cited in a proper way. So you can also add a specific license. Again, I insist on this because it's quite important, like Creative Commons, as you can see, is also here, open source license, because in principle, you have to also take into account that when you are using also somebody else resources, somebody else library, etc., be sure that take a few seconds to read also the license or to see if they even have a license, because again, this is very important, because in principle, don't having a license basically should be translated as you are not in principle allowed to use it freely, and you should ask. Let's say it's not the opposite. You usually feel on the internet, but when it's a missing license, the proper way to read that will be say you cannot use it, and you should ask, basically. So it's good practice, extremely good practice to do it. So yes, again, we don't go through all the detail, but you can upload a sample. You can obviously browse some data sets, paper, again, courses. There are some collections here, and this project is backed up by several institutions. So I have been there for many years already, and I find it quite powerful also. So here again, a couple of examples of where you can save data and also obviously explore different data. I am trying to soon to let me change the tab. So yes, a couple of resources in that area of the data. So let me go now to the analysis platforms, environments, like for example, Jupyter, as again, has grown in popularity and started to be, well, not started since already years, kind of standard for several domains in data analysis, different science. And there is, they say have been popular enough that some other companies and other services started to integrate Jupyter as it is into their platform instead of creating a new one, But also there are variations of the same idea. So here there is a couple of examples. One of the first thing to mention is this Jupyter Hub. Jupyter Hub is essentially the multi-user version of the Jupyter, basically. So what happens sometimes that you will be allowed to use, let's say, one of these resources, or maybe you are one of the persons who set up this kind of resource as a system administrator, as a DevOps. So Jupyter Hub essentially allows to have a server, or more than one, but essentially you can imagine a simplest way, a server where you can create accounts and people can come and run Jupyter notebooks in that particular service. So again, it's a infrastructure, it's a software as a service in that sense. So yes, what is here is essentially the structure because what it is and how to deploy your own Jupyter Hub. And there are also containers for that, and it's quite straightforward in some cases to do a simple setup. But so one of these setups that is freely to use is called MyBinder. Maybe you already use it. MyBinder is a quite powerful tool and also famous in the sense that allows you to have the possibility to run Jupyter notebooks anonymously for a certain amount of time on a computer for free, basically. And it can be very, very useful to prototype your analysis, your setup environment, your Docker, your containers. Yes. So in this, as you can see here in the user interface, it's quite simple. Essentially, sorry, what it does is that you can turn, as you said, any Git. Okay, Git, so it can be a repository in GitHub, can be Gist, GitLab, as you can see, as a node DOI. That is obviously reading a Git repository and some others. So you can take one of these. For example, let's take the one from the school. So if we take our Git repository for the school, as you know better than me, you have been already using some notebooks given by instructor in previous classes, so we can put this repository here. Can be the generic repo, let's say the name of the repo. In this case, we'll take the main branch, but you can also define a particular branch, a particular tag, or even a particular commit that you want to test, and even the path of the particular notebook. That is, these two things are optional. And this will also generate this little button that you maybe saw already in some other repositories. Essentially, will allow us to launch others to simply click that button and launch on MyBinder your repository, and test your notebook. So this is exactly what I am doing right now. I am taking the repo and launch it here. But again, this create also this little banner button that are quite useful to add into, for example, back into Git repository. So this can take some time depending of the repo, depending obviously of how busy the machines are. In this case, it's quite maybe quick, and it's because I already run it. So one feature of MyBinder that you may want to know is that if for example, just before this lecture, I execute this one. So if there was no any change in the repository, the building will be very quick because MyBinder save image of previous, as you can see, previous containers that were executed there. So again, that can be very powerful. For example, you are running your particular workshop, a smaller version of this school, for example. You can prepare your repository, tag it, or use a particular commit in the form that we just saw before. And so you execute it a couple of times, and your users, or the people that you are, your trainees, etc., your colleagues, when they use the same link, it will open much quicker because MyBinder will not need to rebuild the container again, the setup or by scratch. It just essentially compare and say, okay, this commit is something that you already have in the bank, and just bring it to you, and will be much quicker. So the first time usually takes time if it's completely new for MyBinder, but when it's done once, the next time will be much quicker. So saying that, again, you can see that it opens and it shows you this the same structure like we have in the repository, and the same that you install in your local computer. I know there is a couple of notebooks here. I will not obviously explain because it was already explained very well by the author of this, but I can open this folder and open one of these, for example, advanced feature. And so you will have exactly the same environment. So this is, once again, this idea of reproducibility. We are using in my binder exactly the same notebook from Enrique that was that you were using on your laptop. Okay. So we can, for example, clean the kernel here to show you that it's running. So all the cells are clean in this case, and we can run it all, for example, no? Just to test. And there is, the output of this particular notebook. Another quick also observation is that Jupyter usually have a kind of this not trusted. So it's a kind of protection because, of course, some of the notebooks at the end is code that is running in this particular computer. And so some of the features are disabled, like, for example, some of the notebooks need some JavaScript application in order to allow you to do some animations or some interactivity with the output. So if you, for example, see that some of these outputs are different, it's because maybe it's behind this protection, and we can always, if you are sure that it's a notebook that you can trust or something that is your own, the notebook, you can say, I trust in the notebook, and it will reload. And if it was a resource or particular animation application that was not running, it very probably happens this time that will be visible, because now you are saying to my binder, hey, yes, trust in this notebook is fine, the code that is executing. So yes, this, for example, is one of these. I want to take just another one here. I think here. Yes, here's was another one for yesterday classes, Tama. And we can do the same operation. No, we can trust, for example, from the beginning. We know that this is a good notebook, and clean the output to be sure that all these plots goes, different outputs, and execute this once again, run all, for example. So it's doing different graph and producing the output. As you can see, it's quite powerful. It's quite useful. You can, again, if you didn't see it before this, I invite you to use it. It will allow you to do this prototyping, to test, and if you are using somebody's computer for free for a certain amount of time, and so this is something that you can profit very easily. And when I say for an amount of time, is that you can read the details of my binder, but I think that they ensure, let's say, in some way, up to 2 GB zero memory. For example, this is the metric that you see here. And I don't remember 100% sure, but I think it's 10 GB of storage that you can have. So, for example, you can also open a terminal and download some sample here and use it locally. I mean locally in that virtual machine that was created for you, the particular instance. And it will be a few hours. I think that the 4 hours are ensured. They say, sorry, they tell you 4 hours. You can be sure that the notebook will be for you. And after that, we make, they kill the processes, because the idea is that they have to give the opportunity to other people to use the system. So if you left the notebook doing, just theirs without doing anything, and you combine a couple of hours, very probably your session will be expired, in the sense if there is no activity. Because again, it's a free resource that they try to maximize the amount of people that can profit of that. So we run a couple of those notebooks again of previous lectures in my binder. The look, the makeup, the user interface, the user experience is exactly the same as everywhere. So this is one of the things about the standards. but there are also, and I think I saw also some mention in the slide already of Collab, that is this collaboratory, that is a tool from Google that allows you also to have notebooks. So for example, here is, when I click that link, opens in my session, my account. But if we cancel this, for example, they opens a demo version, with some Python, and there is some extra information about the cells, etc. You can run the individually and see the output. So it's quite similar to the Jupyter in that sense, but allows you to also use some free resources there at a certain point inside Google. So again, it can be a very powerful tool to test, to prototype some ideas. And I think I was mentioning in the comments as well in the Slack, is you can share the notebook on more than one person, and in a similar way that you do with a Google Doc, for example, and can be also be a useful tool in that sense. You can share the notebooks. So again, I will not go into the detail, but I wanted to show you that this exists for some of you that didn't know, and you can use the computer power, for free, and test your ideas. Include some things like a TensorFlow that obviously is native for Google. So this kind of thing that maybe you can explore the environments and decide if some of them can be useful for you. There is also the way to run notebooks, let's say Jupyter notebooks on Google. And they will also bring you to the console where there is this cloud computing resources. So you can also manage, let's say, your Jupyter Lab, and we will see a little bit of this Jupyter Lab interface in a video I have. So you can have instance of that. There is a free trial. I already use it. So if I try, they will say that I already use it, but they have been very useful. It lasts a lot if you are doing individually and again testing the resources and learning, how to do these operations in cloud computing like Google. So I also invite you to try if you want. Again, this is not collaboratory, but again, Jupyter, as you already know, the Jupyter that you already know. Continue with this. Again, we mentioned my binder. Yes. Then again, there is more companies, especially this tech company, that allows you to use resources for free in their infrastructure. And I just put a couple of links here. For example, you can make an account inside IBM and also run Jupyter notebooks. So as you can see, they don't have their own particular notebook. They bring Jupyter into their ecosystem. And there are several examples here about how can be used. So I also mention here because can be something that you can profit. There are tutorials also on how to run some notebooks here and to for example, TensorFlow, etc. So it's quite rich also. And they said the prerequisites, you have to have an account like in any other this infrastructure and run the time. So, and I encourage to do this because it will allow you to have at least a vision of this different infrastructure that you may find, in the future. Because once again, even if you are in the academia, it could be that you finish in using a commercial cloud at a certain point for do part of your job. Microsoft has something similar. Again, the link is there so you can explore it with detail. Microsoft plus Jupyter. Also, I think it was mentioned during previous discussion during the school about the extension that you can add, for example, to Visual Studio to get Jupyter running there, this kind of mixing environment. So, but once again, something I wanted to stress is how Jupyter have been more ubiquitous through the different enterprise in this case, and how have been embraced, because the fact that the community is bigger and bigger and bigger, and it's a product that have strong support that people say, okay, let's just take it and improve it instead of doing something new from scratch. So the power, sorry, of this open source community. So, in terms of the Git, and again, inside the continuous integration and continuous deployment, there is also, again, a few examples here. You already know quite well GitHub, and you can create an account, have your repository. You will see more in deep about the CI/CD also in the afternoon, but it's not the only one. So you also have BigBucket by Atlassian. That is a similar fashion. I will open an incognito here, just I can see like the welcome page. So yes, essentially allows you to have private repository, have connection with Guitea, etc. Obviously, it's products of the same company, but it's essentially you can do more or less the same that you are doing, for example, right now in GitHub. And I mentioned for example, if I open now here, if you open in my account that is completely empty, I don't particularly use BigBucket, but it can be also something that you can explore and have resources, and again, to not only store data, software or repositories in general, but also to have this CI inside. There is GitLab that is more and more popular among, especially in the academy, in the open source community. And one of the reasons is that, and also BigBucket that's the same, is that you can install your own instance of GitLab. Yes, so GitLab offer the software for free, and you can install it in your own facilities and have an instance of GitLab managed by you. But again, with all these features to have the have repository, have the continuous integration, and all these things there. So it's very similar. The only thing maybe I can mention is that in GitLab, it's not called pull request, but it's called merge request. But it's again, it's something that maybe you would like to explore, because once again, you may find it, especially if you are working or studying in a university or a public institution. Very probably they will have a GitLab instance for the users. There is even simpler solution. For example, this is Guitea, and Guitea is essentially as a self-hosted Git service. The painless depends, but I mentioned because, for example, we at Atlas use this Guitea for some of the particular things that happen close to the experiment, because sometimes the solution that I just mentioned before are sometimes too big for the issue, or better say, for the application that you want to deploy. And sometimes something lighter and that will be easier to manage, because you maybe have 50 users and no 1,000, 2,000 that it can scale with GitLab, but maybe many of these features you don't really need it. So maybe, again, I just mentioned this one because I used it before, and I know a real case when it's used for specific cases when it's encapsulated, and basically all other solutions are just simply too big for what you want it to do, but still you need a version system with a user interface, a graphical user interface, that can be something to do also. So I mentioned this one here. There is also, let's say, their own Guitea, so that means that you can create an account and try it. As you see here, there is a test only, so repositories will be clean anytime, but you can explore it and see if it's something that can be valuable for you. And again, with this compromise, I said maybe I don't need all these features, but it's good because it's light enough to run it in a more smaller computer, things like that. So yes, few solutions in terms of the GitLab and CI/CD that you can, again, rely like in the software as a service in terms of GitHub, because it's they put the servers and you connect to that. Also these two, but in this case, you can also get the software and manage your own instance. In terms of the computing infrastructure, again, my binder will be the easiest example here also, because allows you to as you saw, to encapsulate, in this case, sorry, the Docker and the environment allows you to encapsulate an environment, sorry, and my binder will allow you to execute it. So I put an example here that also, again, part of the things I do in open data, so I can talk properly about it, because other thing that you may use is not only container, but also maybe virtual machine. Virtual machines can be also a very powerful tool in particular environment. For example, you will need to encapsulate an entire environment, including the operating system. So, for example, the virtual machine is a good option. Also, it's important to remember that many of the commercial cloud, when you call an instance, what it means is most probably it's a virtual machine, you know, in Google Cloud or in Amazon Web Services, etc. and Azure. So the understand how to create a virtual machine can be also very, very useful, and you can, you know, have this portability that again, it's not a competition between what is a container or a virtual machine. And sometimes you will very much find a virtual machine a very quite powerful tool. So, for example, we use it in for education. So, just to give you an example, we have this virtual machine that is an Ubuntu virtual machine with some things inside, like root, that is an analysis framework for particle physics developed at CERN. We have Jupyter with several kernels. And you already know about this. So we have a few collection of kernels that allows to run different language. And also something that is very important, these virtual machines are stored in Zenodo. So this is why I also wanted to show you this example. So if you click here, this little button, similar to the MindBinder, if you see it well, is also Zenodo give you the markdown how to create this little button. So it's quite useful. So if you click here, it will bring you to the record on Zenodo, and you can see you can track this. Also bring this example because if you notice here, they said there is a newer version of this record. So what can happen is that because the virtual machine evolved, you know, we found a bug and we repair it and we put a new version, or we put a new kernel, or etc. We can keep the machine still useful, but under the same main DOI, let's call it like this, and you can have several versions of the virtual machine there. So if you click this newer version, so the last one was 26th of February of last year, and still is very much used. As you can see, the amount of people have downloaded and viewed this record is very encouraging to have this kind of thing. And again, the machine have been evolving. It's not a single record that, you know, was put on rock. But if you enhance, if you improve that particular record, you can still keep it into the same under the same umbrella, and so it will be easier to track instead of create an entire new DOI for something that it was essentially a new version of the same thing or improved version of the same thing. So it's also better for this kind of counting, no, and tracking back how the people is using your resources, or if they are using it, basically. There is more detail here about this. So yes, again, you can also use virtual machines. These virtual machines, let me open back this. We encourage the people to use a VirtualBox to install it, for example. Something that you can imagine is in some way similar to what we would do with the Docker. So you will have an application that allows you to run this virtual machine, in this case, and the Docker app, desktop app will allow you to maintain, to have more than one virtual machine, for example, or in the case of Docker, more than one container. So it can be also very, very powerful, because sometimes you don't want to install all these things in your machine. So you want to maybe have a virtual machine that you are dedicated for a particular example. Maybe you are testing something that can be destructive for whatever reason, and a virtual machine can be the way to to open files there and to do stuff in a completely isolated environment. So it's not only in the sense that replication, like in the final pipeline, but something that you can have and have different environment that are freeze there in time. So yes, in my binder we mentioned before. So can I skip this one? As I mentioned, for example, we use the virtual machines. This is we call a classical example in the sense, if you download this machine that is there, essentially allows you to run Jupyter notebooks as a service, as a server, sorry. So what it means is that it's not like for those of you who are familiar with a virtual machine, especially if you have a graphical user interface, you will have like you have maybe Windows or Mac and you have VirtualBox, and inside you put an Ubuntu machine. So you will see a small window with the Ubuntu user interface, not the desktop there and the icons, etc. But this usually is very, it consumes a lot of resources. So if you go inside the virtual machine, let's say, and start to click as you will use it with a real machine. So in this case, the approach has been that we use the virtual machine as a mini server, let's say, and what there is contained Jupyter and a bunch of library and stuff, so that people don't need to set up this to run the training similar to what we're doing right now. But they will access to the notebook, for example, to the Jupyter in the real machine. So in the browser of the real machine, the machine that has VirtualBox installed. So you connect to the virtual machine very much the same as you were doing with my binder. The only difference that here, instead of the sorry, well, I cannot make it bigger, but instead of here, see this hub, Git, my binder, etc. You will see localhost, But what it means is that you are connected to your own virtual machine, your own mini server, say there. So you are not using the graphical interface of the VM. That can also improve the use of the resources of the machine. So yes, we already discussed something like this, when you can have these resources coming from the internet, the open access, and using, for example, the virtual machine to run, or we will see some containers. So this is quite the same. Also, I have the Jupyter Lab interface. The Jupyter Lab is already the standard user interface for Jupyter now. Let's say, have been switching little by little between the two, and it looks more in this sense, where you have a more complex environment, let's say, but useful in the sense that you will have an area here on your left where you can see the different files. You can see tabs like which notebooks are running. You can also install particular extensions on top of the Jupyter Lab, and so you will see them here. You will also have the opportunity to have more than one windows together, so that can be quite powerful to run more complex analysis. For example, you can have a terminal and a notebook and a Markdown all at the same time, and just clicking between the tabs to change. So passing from more of this model that you have your machine running a command that is executed in a machine and reading the data. So yes, sorry. What I wanted to mention here is that you can also use Jupyter Lab to run commands, or Jupyter that you have. You have the opportunity to get a terminal, and so that can be also a very powerful tool, because you don't need to. It's not only the fact that you can run notebook, but that the Jupyter itself can be an interface to the terminal that I think many of these, if you know all the instructions, encourage you to get familiar with because will be quite powerful in the future. So if I come back to the session that I have here in my binder, you will see that one of the buttons here says new, and I can open a terminal. That is exactly what it was showing to me in this short video. So I can still, explore what are the, as you can see here, I am inside the user, let's say, of this particular machine I am using. And there is all these folders that, for example, here is the folder from the, oops, where are these 3 notebooks for one of the lecture? They are here. Something that, for example, if you have this terminal, you can essentially also clone a new repo. For example, imagine that you have my binder here that you open, and I can still come here and take the URL, come back here, and git clone that repo and go inside and work. So for example, you can clone another repo there, that you wanted to use. So this should be here, this one that was done a few seconds ago. I just want to do a little experiment here and then try it, because essentially you can change the tree for lab, and it should change you to the new interface, or the Jupyter Lab interface. That's what I was mentioned you also. So you have obviously the same files, but here you can explore the notebook, for example, this one that we were running already. You can see here what is running, for example. So we have this terminal, we have this notebook here, and you can see you have this tab that is called Launcher, where you can have, you can create a new notebook depending on the kernel that you have, or the console, or launch a terminal, text file, or Markdown, and the help. So you can, for example, also create your readme.md and start to work here. So I encourage you also to see it, because it's the user interface that is now. If it's not now, will be by default what is Jupyter, essentially. So yes, this past this one. So I was more wanted to say that that we can use the user interface, the command line user interface, but also the graphical user interface. And this is what you have done until now, that using the notebooks. There is another video here that essentially will show you the same that I was mentioned before. You can get the user interface. You can clone your repos there, do your analysis. So this particular video is not, it's done locally, let's say, but you can imagine doing the same in my binder as I have open right now. You imagine that you use this infrastructure to improve this notebook in some way. You can push back to your repo and close the session, and profit of the fact that somebody is essentially giving this computer for free for a few hours. So you can also, as long as you have your repo up to date, you can migrate between your laptop, my binder, or other infrastructure that you are able to use to do your job. So that's quite powerful, at least from my point of view. You can jump between them. So yes, again, the videos have essentially some cuts of the thing that you can do here. So container using Docker. So again, as we mentioned before, maybe many of you, if all of you already have the Docker desktop application. We put some instruction in the README of the repository of the school. And here there is a couple of links that explain very well by Docker, for example, what is a container, But it's also here a container allows you the preservation and the reproducibility of software environment and application. So, and it's happened that, for example, you have a container, a series of containers, and you execute it inside a virtual machine. So these things can be also complementary. If I insist, for example, if you launch an instance in OpenStack or in a commercial cloud, it will be a virtual machine, and after you inside the virtual machine install Docker and run several Docker containers. So there are details, obviously, why they differ and what are the properties of each of them. Why, for example, in terms of doing these software environments and application, Docker is quite powerful to distribute, also in the management of the resources, the computers that are using, etc. So it's a very powerful tool. You will use it also in another lecture. So the reason why it's here is that first that you get the application because it's relevant for the courses. If you have more questions about what they are, what they are able to do, and so what you will see is if you have the application installed, and this is why I have my entire desktop share here, is that you will have this desktop application. It's called the dashboard, where you have your containers, the ones that are running, exit, off, the image that you have you have created or you download, you got from the Jupyter, sorry, for the Docker Hub, and I will show you what it is. And there is more feature. Obviously, this is a business model when many features are free, but if you go farther or you need more complex stuff, you can pay for Docker for that. But it's a very common model, in many of these companies. So what is relevant for us, once again, is to get with the application. And the other concept that I have here is the Docker Hub. The Docker Hub is essentially a way to save Docker containers. Yes, so so again, imagine that you are producing a particular software and you are releases and new tags, new features, etc. Different flavor of the same software. Docker Hub is one of the ways that you can, expose those containers to the public, so they can be downloaded, they can be pulled. That's the way that it's called, and you can have a collection. In this case, not of the software, as you will do in Jupyter, in GitHub or in GitLab, but a collection of containers with tabs, with different flavors, etc. So in my case, I only have one, and this is the screenshot that I have here. I have one that we are essentially is a clone of a repository of my colleagues here at lab, and testing different features there. But if we, for example, we explore another project, and I have it open somewhere here. Yes, this is a root that I think I mentioned before. Is a analysis framework, especially for particle physics, develop that term. But the key thing about what I am showing you is that you can see here the collection, let's say, of repositories, the collection of containers. In this case, like the official Docker image, and maybe some flavors. Some of them, as you can see, this image is depreciated, but it's still there because coming back to reproducibility, maybe they are, or maybe not, they are not outdated anymore, but maybe there is people or analysis that are relying on that container to preserve a particular analysis. No? So this is, for example, what they continue existing there. This can be something that you can also do, even if you don't, for some reason, freeze that particular container. There is part of this idea of reproducibility, where you have your setup to be used later in time. So just clicking one of these, essentially, again, you can be very explicit or let's say give us many detail about what it is, and it's a complete README You can write this in Markdown if I remember well. So, and put your own resources. So you can see here also the source repository is coming from a GitHub. This is part of this continuous integration, continuous deployment. So the container is created in one of these servers and send it, or let's say injected into the Docker Hub account so people can grab it from there. So it's all this, and this is also automatized. So I think this is one of the last thing I want to ask you is that there are several Jupyter containers, so Docker containers containing Jupyter. If you click in this particular slide, slide 50, it will take you to a documentation on how to get a Docker container with Jupyter. So for example, this can be another way also to get the Jupyter environment in your computer, another way to do it. So in this particular example, again, not to go into the detail in all the text, but essentially it shows you here that is several examples, example 1, example 2, to get an image of this Docker container. In Jupyter, it's called SciPy notebook, and not also here they have a dedicated tag. So in this case, it's a tag inside Jupyter, inside Docker Hub, sorry, of this container. So this is a command line that you can execute in your terminal. So I will just copy this here, and I already have a terminal open here, and I will paste this line. I already did this before, as you can see, when I will see in real time, but it will, I hope so, will go fast, very fast, let's say, but in your case, it may take some time because it will bring all the different pieces of the notebook, of the container. Sometimes happen also that the container are starting from a previous image. So again, the container is calling another container as the base, as a base container, and on top of that, it puts more stuff. No? So this is also a very powerful way of building container. You can take something that you already know that is well defined, and you simply want to improve, or you want to include an extra tool. You don't need to write entire Docker container. You just bring that one as the baseline for that one and include tools on top of that, for example. So as you can see here, after the execution, there is a URL, sorry, it's here, where we can copy this URL in our browser. I have many tabs now. Let's put it here at the end. And also show me the traditional, say, Jupyter user interface. We can change in the same way, changing 3 by lab. And here we can do exactly the same operation. We can, for example, clone our favorite GitHub repo. We can, in this case, for example, open a terminal here. Maybe make this a little bit bigger. And say git clone repo. The one is clone, it should appear here. You can see school 2021. And I can also, once again, look for my notebooks. Take another one of this one. This one, for example, is clean here. No, the cells are not executed. So I can also run all the cells. All the cells. It runs all the cells. Yes. So here you have the output of your notebook. So again, it's still, as you can see with the star here, still running some of the processes. Finish for this one, finish for this one. And again, it's quite nice because you can have more than one of these windows or tabs together. Also explore the notebooks that are ongoing right now. This is also quite powerful if your notebook is well done, in the sense that, for example, here it's well done. For you have a title, you have these subtitles, heading 1, 2, 3. This also will appear here, so you can navigate the notebook with that in table of content, let's say, not created if you use in the proper way these Markdown functionalities. You come through the kernel and jump to a particular part of the notebook. So again, it's quite powerful. And in this case, it's again another way to get Jupyter Lab, in your environment. For example, is through containers. And this is something I hope that you are following with me, or you will do it also after. This is what I was in this slide. Is a screenshot a little bit of what you may see. When it's the first time, it will start to pull in different tools that are the components of that Docker container. And again, if it's the first time, let's spy here this application. Jupyter SciPy is 2.64 gigabytes. Yes, it can be large. Some of them are a few hundreds of megabytes, etc. So this is the different things that I had to bring. Let's say, or better say, the Docker container contains several tabs, and you will see this downloaded one by one happening. And when you finish, you will have exactly the same thing here, a URL with a particular token where you can open it and work inside your Docker. So this is, yes, we are almost on time. This is exactly what I was doing during the last minutes. Essentially, install Docker and reproduce one of the notebooks that you have there from previous lectures. So this is pointing to our repo, and hopefully you have been followed that also with me. And I am very close to the end. I just want to show you maybe a couple of things that you, let's say, an extra reference, basically, that can be useful also. For example, this particular platform also developed at CERN, but it's not CERN exclusive. So it's called REANA, and stands for Reproducible Research Data Analysis Platform. It's REANA, let's open it here. It's exactly the same here. Allows you to integrate, in this case, more or less what I was talking to you, this entire pipeline, from the code, the data sets, the Docker containers, and there is several examples of how this is done using open data from several experiments. For example, here, let's open this because I am a little bit biased, obviously. And it brings you to the GitHub with all the different parts. So of the analysis that you can reproduce completely using the REANA environment. So again, it's not like I go into the detail now, but I invite you to see it, because you can see real example of how this can be done. And why not? It can be also a resource that you can use for your own job, for your own work. And to help you with that, there is a tutorial done also around reproducible analysis by the Awesome Workshop community. You maybe saw previous tutorials like this. This is a High Energy Physics Software Foundation and Iris High Energy Physics. So, but essentially is to have these detailed tutorials on how you can use REANA, for example, in this case. You can follow this tutorial. You don't need to be part of any collaboration to do this. And we'll give you a hint, very, very practical exercise of how to use this tool. maybe you are already familiar with this template, because this template is from the Carpentier, that are quite useful, famous and useful. Yes, sure. Notice this also, please. I insist on that because it will be very relevant in terms of the thing that you should do with your analysis, with your code, with your documentation, etc., is to have license for those and to let the user know what they can do with the resources. Maybe you can clone this repo and enhance the tutorial, take it with you, create your own on top of that, and what are the implications. You should point that this is a derivation, a job from this particular tutorial, etc. And one of the reasons of this school is also to encourage to follow all these kind of yes, I would call it protocol of how to deal with the resources created between us. So the community is building the confidence that all the participants, basically. And so yes, then last comment here, there are many other points in terms of reproducibility when talking in large scale, but I will not go into detail, but there is a few extra text about the publication systems. Rachel also mentioned when you have the archive to put the final paper, but also the data sets, the DOI, that is quite important for any modern track of scientific and technical contributions. It measures the impact, the research in a modern way, especially for kind of resources that doesn't fit into pattern or citation of a paper, especially when I add software, for example. Repositories, there are many ways to do this. There is a repository for data, as you saw, for code, for software environment. Let's call it virtual machine or the Docker container, the Docker Hub, for example. There are all these different repositories, and you can essentially, if you remember that slide from Rachel about the different paths that you can take, you can draw your own path, taking the tools that really can be useful for what you are doing. And more and more these systems are common. Let's say in terms of the computing, we talk about again virtual machines. You can deploy virtual machine in different cloud services. How this infrastructure and software as a service are more and more common. For example, one of these particular example is Jupyter in this case. Also, there is aspect in the monitoring, but again, this is more for large installation here. The storage, we also mentioned about this. There is also this kind of voluntary and academic storage. We saw on this platform like the academic torrents, that is essentially a community that borrow part of their resources so others can profit and take the data sets and make easier the distribution of those data sets and those resources. The bookkeeping is quite also important, keeping more in terms of the documentation. What is the final place where you put all these pieces together and can be easy to find. And we talk a lot about, again, software, the importance of the continuous integration, how this automatization has to be something that you need to explore and try to find which pieces of what you are doing can be automatized, and so make your job easier, make it reproducible once again, and save some time and maybe some reduce the probability to make a mistake, for example. And since this is the last slide, this is exactly the same slide as, well, not exactly, but the same text I mentioned before, so I will not read it again. I really hope that one of these concepts help you to understand better what are the different scenarios that you find and you may find, that help you also to come back to the piece of paper and draw your pipeline and try to identify your different objects. And after you do that, you can choose the right platform for your case and do it in a proper way, let's say from the beginning. So thank you very much, and don't know if there is question because I closed my Slack. So, I mean.
Okay, thanks, Arturo. Yes, so there is some question. So first of all, like about Zenodo. So the zenodo.org is hosted in the CERN, if I'm not wrong, right?
Yes, yes.
So like is there, how can I say that? Can someone install his own Zenodo instance?
I think yes, because Zenodo and Zenodo is built on top of Invenio, if I remember well, powered by Cell Data Center and Invenio. Yes, so that means that you can have your own Zenodo. Let's say, I don't know if it. I guess it's the case, but you can see here there is the GitHub, so you can go directly to the Zenodo and get your own. You say, sorry, install your own instance of Zenodo. So I think the short answer should be yes, because it's running in Venue and that's possible.
Okay, and like why someone will do that?
That's an interesting question. For example, in fact, I have a real case, a university in Latin America who asked something like this because the university wants to create their own. They want to be have this infrastructure, obviously profit or all what I show about Zenodo, so not to have to build all these things again, but they have the opportunity to have these closed data sets and be able to maybe put a single sign-on in front, so the users, means the students or the researcher, are the only one that can access. So there is use cases where you have an institution that would like to have the same environment, but behind a wall, because again, it's quite normal, no? That some of these things, theses, etc., laboratory courses can be behind this institution. I don't know. The only thing I really don't know is how this is the part of the DOI, because at the end I know there is some kind of thing that you have to pay to get to generate those DOIs. But
Okay. Okay, thanks, Arturo. On Zenodo again, like you show how to upload the VM on Zenodo. Can we do the same with the Docker container also?
Yes, yes. I mean, at the end, the container will be a file. So,
okay.
So you can essentially drop it there, and if it's no more than 50 gigabytes, it should fit there.
Okay. All right. On Docker, like you presented the images and the containers. Like, can you briefly explain maybe the difference between those two things, containers and the image?
Yes. So this is what I know, and again, some of the teachers can jump here and help me. But the image are, let's say, the container that you download, let's say the all this software environment that is encapsulated there is in the container. And so, but and the image are in that sense that box, let's say, that is coming, and the container will be instance that you create of that image. So you can run more than one container from the same image. Okay. So this is the way that I understand it, but it's
okay. Then also, like, there was a question about the difference between my binder and Docker.
So my binder use containers to run. So again, when I open the user interface, again, the web application here, what is happening when you put a URL, a particular Git repository, my binder will start to build a container for you. So it will read the requirements that are inside the repository. I can, for example, show you another example that I know well because it's part of the thing that we do. In open data, for example, very quickly, just to show you, notebook here. So here we have also this launch binder, for example, there, and similar to what is also in the school repository, we have the environment that essentially is asking for root, pipe, very similar. And my binder essentially read this, and with that create a container, and this is what is given to you.
Okay.
So
okay, I think it's clear. And that's all I have. Oh no, yeah, there was also this question like when you use my binder, does it mean that you don't need to let's say you want to process some data, it means that the data you don't need to download them on your laptop and on your personal computer. They are managed on the my binder website, right?
yes, exactly. So for example, here, if my session is still alive, yes, you can, you open a binder, with a particular repository, you clone your own repo. One of the things that you can start to do is, for example, do a wget, and get the files that are on the internet. Or you can come here to the, I think I will change it for the classical, but it's here. Yes, don't restart. Let me just go back here. Yes, please. You can upload also. So you have the opportunity also to put data if you have a local in your computer, put it inside my binder. So in this particular instance that is created for you, or again, read it directly from the internet. So again, there is a limit here. I think it's 10 gigabyte maximum, if I remember well, that you can upload on your session in my binder.
Okay, thanks, Arturo. So I don't think we have more questions. So it will be the end of the presentation. Thanks very much.
No, thank you very much.
And so for the Escape School, the next lecture is going to be in 1 hour, 30 minutes. Yeah, so thanks for joining and see you later.
Thank you. Bye, guys.
Bye.